Hello everyone, in this video I'm going to discuss the example for limits. So kindly refers to the question, solve the limit when x approaching 0 for the function where we have the fraction 2 minus set x plus 4 over x multiplied with the x plus 1. First of all, kindly substitute the 0 into the function. So where we have the situation 2 minus, if we substitute 0, then we will have set 4, which is equals to 2 as well, over, if we substitute 0, multiply with the 1, then we will have 0 over 0, where we have indeterminate form. So where we have the strategy would be conjugate, factorize, and long division. So for this case, my suggestion would be multiply by the conjugate. So limit when x approaching 0 for the function when we have 2 minus set x plus with the 4 over we have the x multiplied with the x plus with the 1. So here we have the conjugate 2 plus with the set x plus with the 4 over 2 plus with the set x plus with the 4. So kindly expand the situation. Do remember only expand for one part, which is the numerator. So it refers to 2 minus set x plus 4 multiplied with 2 plus set x plus 4. So where we have to apply the formula where we have a squared minus the b squared. So limit when x approaching 0. So here we have 2 squared minus we have the set x plus 4 squared. So where we have x plus with the 4 over x multiplied with the x plus with the 1 multiplied with the 2 plus set x plus with the 4. So kindly simplify the situation. Limit when x approaching 0, then we have the negative x over x multiplied with the x plus with the 1 multiplied with the 2 plus with the set x plus with the 4. So if we simplify, limit when x approaching 0, where we have negative 1 over we have the x plus with the 1 multiplied with the 2 plus set x plus with the 4. So if we substitute the 0, then we will have the situation. So in here we have 1, in here we have 4. So we will have negative 1 over, here we have 1 multiplied with the 4, set 4, where we have 2. 2 plus with the 2, then we have the 4. So limit when x approaching 0 for the function, bracket 2 minus set x plus with the 4 over the x multiplied with the x plus with the 1. The value of y will be approaching negative 1 over 4. Kindly refers to b. Limit when x approaching 2 from the right. And we have the function modulus 4 minus with the 2x over 8 minus 2x minus the x squared. So kindly focus on the situation where we have to define the modulus. So modulus 4 minus 2x. So 4 minus 2x negative bracket 4 minus 2x. And then the domain where we have 4 minus 2x greater equals to 0. So we have 2x less than equals to 4. So x less than equals to 2. So here we have the domain x less than equals to 2. Here we have the domain x greater than the 2. So continue the situation. Illustrate the situation in a real number line. We have the 2. X greater than the 2, we have negative bracket 4 minus the 2x. X less than equals to 2, we have 4 minus the 2x. So continue. If we substitute the situation in here, we will have 0 over 0, when we have indeterminate form. The strategy will be multiply by the conjugate, factorize, or long division. So for this case, my suggestion would be factorize the situation. So limit when x approaching 2 from the right. So focus on the situation from the right. We have negative bracket 4 minus the 2x over. Factorize the situation. Do remember not to use the calculator because of the negative x squared. So factorize and we will have 4 plus with the x and then 2 minus the x. Kindly simplify the situation given. So limit when x approaching 2 from the right. So if we factor out the 2, then we will have negative 2 bracket 2 minus with the x over we have 4 plus with the x and then 2 minus with the x. So notice that we have the common terms in here and also in here. So simplify. Limit when x approaching 2 from the right, we have negative 2 over 4 plus with the x. Kindly substitute the 2 and we will have negative 2 over the 6 where we have negative 1 over 3 for the value of y. Hello everyone, in this video I'm going to discuss the example for differentiation. Find the derivative for the fx, where we have the function 1 over 1 minus x using the first principle. So here we have the formula for the first principle. So continue, kindly substitute the situation. Limit when h approaching 0, we have 1 over 1 minus bracket x plus with the h, minus we have 1 over 1 minus with the x over the h. Kindly equate the denominator. So limit when h approaching 0, we have 1 minus the x minus bracket 1 minus we have negative x negative h over we have h multiplied with 1 minus bracket x plus with the h bracket multiplied with 1 minus the x. So kindly expand and then simplify the situation given. So notice that in here we have 1 minus the x minus the 1 plus with the x and then plus with the h over we have the h bracket 1 minus the x minus the h 1 minus the x. So limit when h approaching 0, we can see that we have 1 minus the 1 0, negative x minus the x 0, so we have the h. And notice that in here we also have the h, so we can straightforward simplify. Then we will have 1 over 1 minus the x minus the h bracket 1 minus the x. So if we substitute 0, and we will have 1 over 1 minus the x bracket for 2 times. So f prime x, and we will have 1 over 1 minus x bracket squared. Kindly refers to b. Given we have the situation y is equals to sine x over 1 plus with the cos x. Let's say here we have u and this one we have v. Find the dy dx. So make use of the quotient rule. We have y prime equals to, we have v u prime minus u v prime over the v squared. So let's begin. Dy dx equals to v, when we have 1 plus with the cos x. Differentiate the u, so we will have cos x minus sine x. Differentiate the 1 plus with the cos x, so we will have negative sine x over the v squared 1 plus with the cos x bracket squared. So continue, we have the cos x plus with the cos square x plus with the sine square x over 1 plus with the cos x bracket square. Notice that in this part we have 1. So rewrite the situation, 1 plus with the cos x over 1 plus with the cos x bracket square. If we simplify, we have the first derivative which is equal to 1 over 1 plus the cos x. So now continue when x is equal to 0. If we substitute cos 0, we will have 1. So the dy dx is equal to 1 over 2, where we have the gradient which is equal to 1 over 2. Hello everyone, in this video I'm going to discuss the example for application of differentiation for the experiment problem. Find the coordinate of the stationary point on the curve. So where we have y which is equal to x to the power 4 minus 4x to the power 3, and determine their nature. So step number 1, we have the function. Step number 2, find the y prime. So we have 4x to the power 3 minus we have the 12x squared. Find the second derivative. So we will have 12x squared minus 24x. Continue. The third step, we have to find the critical number. So where we have 4x cubed minus 12x squared equals to 0, factor out the 4x squared bracket, we have x minus the 3 which is equals to 0. So x is equals to 0, x is equals to 3. Kindly substitute the function into the calculator and then calculate when x is equals to 0, y also equals to 0. So when we have 0, 0. Continue. When x equals to 3, y is equals to negative 27. So the point will be negative 27, 3, 20, negative 27. So where we have the stationary point. Next, by using the second derivative, we need to test the situation given. So f double prime 0, f double prime 3. So if we substitute 0, then we will obtain 0. If we substitute 3, then we will have 36, which is greater than 0. So from here, we can say that this is the minimum point where we have 3, negative 27. For this case, we still have inconclusive. Then we must refer to the first test, or we can say first derivative test. So kindly refers to the table. So we are going to focus on the 0. So negative infinity until 0 for the interval, and then 0 until positive infinity. The suggested value will be negative 1 for the x, and then here we have 1. Next, find the f prime x. If we substitute the situation into this part, if we substitute negative 1, and we will have the negative 16. If we substitute 1, then we will have the 8. Negative 8. So what does it mean? Decreasing, decreasing. So from here, we can say that since the f prime x is no change for both, then we can say 0, 0 is an inflection point with the minimum point negative 27. Hello everyone, in this video I'm going to discuss the example for complex number. Given that the z is equals to negative 3 plus with the 4i and the zw which is equals to 14 minus 2i. Find the w in the form of a plus bi where the a and b are real number, and after that find the argument. So kindly substitute the situation. So here we have the zw which is equals to 14 minus the 2i. So w will be equals to 14 minus the 2i over the negative 3 plus with the 4i. My suggestion will be multiply by the negative 3 minus the 4i, which is the conjugate. And after that, kindly expand the situation given. W, which is equals to 14 multiplied with the negative 3, we have negative 42. Continue. 14 multiplied with the negative 4, then we will have negative 56i. Then we have positive 6i, and after that we have negative 8 over. Make use of the formula. We have 3 squared where we have 9 plus with the 4 squared where we have 16. So W will be equals to negative 50 over the 25, and then minus the 50i over the 25. So W will be equals to negative 2, negative 2i. So that is the W in the form of Cartesian a plus bi. Next is to find the argument of W. For example, the W is equals to negative 2, negative 2i. That would be the step number 1, having the Argand diagram, so located at the third quadrant. Step number 2, let's say, just an extra, we find the W, the modulus of the W, where we have square root 4 plus with the 4, which is equals to sub8, where we have 2 sub 2. Just an extra. Number 3 is to find the basic angle. So tangent alpha equals to, so the B over the A, ignore the negative sign, so we will have 2 over 2, which is equals to 1, and the basic angle will be the 45 degree. Next is to find the argument of the W, where we have negative 180 minus become plus 45, then we have negative 135 degree. In the form of radian, so where we have negative 3 over 4 pi radian, or negative 2.36 radian. If we want to write in a polar form, so W is equals to 2 sub 2 bracket cos bracket negative 3 over 4 pi plus with the I sine bracket negative 3 over 4 pi. Just an extra polar form. Hello everyone, in this video I'm going to discuss the example for equation and the rational inequalities. Kindly focus on the A. And we notice that we have the situation where we have the situation y is equals to 2x. So kindly simplify the situation. 2 to the power of x bracket squared minus 9 bracket 2 to the power of x bracket. We have 2 to the power negative 2 where we have 4 plus with the 1 over 2 equals to 0. Y equals to 2 to the power of x. So here we have the y squared minus 9 over 4y plus with the 1 over 2. Multiply all the terms with the 4, so we have 4y squared minus the 9y and then plus with the 2 equals to 0. Next is to factorize the situation. We have 4y minus the 1 bracket y minus the 2 equals to 0. So 2 to the power of x equals to 1 over 4. where we have 2 to the power negative 2. Continue, 2 to the power of x, which is equals to the 2 to the power of 1. So from here, x is equals to negative 2, x is equals to 1. Valid for both answers. Next, kindly refers to b. First, what we have to do is to rearrange the situation, and then after that, equal the denominator. So negative 15 minus with the 5x minus we have x plus with the 3 multiply with x minus the 2 because we want to equal the denominator. Next, we have negative 15, negative 5x, continue negative bracket, we have x squared and then plus with the x and then minus the 6 over we have x minus the 2 greater equals to 0. Simplify, negative x squared and then continue, we have negative 6x and then after that we have negative 9 over the x minus the 2 greater equals to 0. Rearrange the situation. So we have x squared plus with the 6x plus with the 9 over x minus the 2 less than equals to 0. Factorize the situation. We have x plus with the 3 bracket square over x minus the 2 less than equals to 0. Next, determine the sign. Continue. X greater equals to negative 3 for 2 times. Then x greater than 2. Kindly illustrate the situation in a real number line. We have negative 3 and also the 2. So then circle, empty circle. So from here we have the negative, 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 negative. So negative, positive. So negative, negative, and then the positive. So based on these part, we are preferring the negative. So from here, if it's a set solution, x such that x is less than the 2. If it's an interval, negative infinity until the 2, where the 2 is not included. Hello everyone, in this video, I'm going to discuss the example for function and graph. So given we have the function fx, which is the piecewise function, sketch the graph for the fx. So kindly refers to the graph. So based on the situation given, we have the negative 4. Let's say here negative 1, negative 2, negative 3, negative 4. So if we substitute negative 4 into this part, if x is equals to negative 4, the value of y will be equals to 15. So here, let's say negative 4, and then let's say here we have more than 15. Continue. If let's say where we substitute 0, if x is equals to 0, then we will have the negative 1. So let's say here negative 1, then we have the empty circle because it's not included. What if y is equals to 0? So we have negative 4x, negative 1 equals to 0. So x will be equals to negative 1 over 4. So means that 0.25. So let's say the location over here. So we have the coordinate. So negative 4, 15. We have the coordinate. Let's say we have negative 1 over 4, 0. So kindly sketch the graph. So here we have the graph. Y is equals to negative 4x, negative 1. So kindly plot the situation. So in here we have negative 1 over 4, 0. Next is to sketch the exponential graph. So now we are going to focusing on the e to the power of 2x minus 1. If we substitute 0 in here, so automatically we will have the situation when x is equals to 0, then the value of y will be e to the power negative 1. By referring to the calculator, we have almost 0.36, something like that. So let's say here we have 1. So here will be the point included, where we have 0, e, negative 1. And then continue. Based on the situation, we have the positive x. So the graph will be something like this. So that is the graph. Y is equals to exponent 2x minus the 1. So make sure we have label x and y, and then including the point of intersection. Number 2. State the range of the fx. So based on the situation, so here we have the range. So it refers to the graph. The range for the f would be start from negative 1, which is the minimum point, until the maximum, where we have exponent. Okay, because x greater than 0, so this one will still moving up. So that is the range. Number 3, evaluate the f row f bracket. We have the negative 1. Firstly, substitute the negative 1 into the f. So if we refer to this part, we have the negative 1. Negative 1 means that we are trying to make use of this function. So negative 4 bracket negative 1 minus the 1. So in here we will have 4 minus the 1, we have 3. So f3, continue, make use of the second function. So we will have e, and then 2 multiplied with the 3 minus the 1. So we will have e to the power of 5. So that is the f, row f bracket negative 1. Continue with the b. The function g and f are given by follow, where a and b are non-zero constant, given that we have the f row g bracket 2, which is equals to negative 5, and we have the g row f bracket 2, which is equals to negative 29. Kindly substitute the situation. F row g, so means that substitute the 2 into the g, where we have 4 minus the 6. So in here we have f bracket negative 2. So if we substitute the negative 2 into the f, so here we will have the situation 4 and then minus the 2a and then plus the b equals to negative 5. So kindly rearrange the situation given. So here we will have 9, which is equals to 2a minus with the b. So that is the first equation. Second equation, substitute the situation here 2 into this part. So we will have 4 plus with the 2a plus with the b. Continue. Substitute this part into the g, where we have 4 minus the 3 bracket 4 plus with the 2a plus with the b. So kindly expand. So we have 4 minus the 12 minus the 6a minus the 3b equals to negative 29. So based on this case, we have negative 8. So if we have negative 8, 29 minus the 8, which is equals to 6a plus with the 3b. So 21 equals to 6a plus with the 3b. Divide by 3, so we have 7, we have 2a, and then we have the b. So here we have the second equation. So kindly make use of the first and second equation. Number 1 plus with the number 2. So 9 plus with the 7, we have 16. 2a plus with the 2a, we have 4a. So a is equals to 4. Substitute a equals to 4 into number 1. So 9 is equals to 8 minus the b. So b will be equals to negative 1. Hello everyone, in this video I'm going to discuss the example for function and graph. Given we have the function fx, which is equals to 1 over 2 multiplied with the surd x minus 4, where we have the domain x must be greater than 5. So a, find the range of the fx. B, determine the f inverse and then state its domain and range. C, sketch the graph for the both function on the same axis. So my suggestion is to sketch the graph. So kindly refers to the situation given. Let's say we have y, which is equals to 1 over 2 and then multiply with the surd x minus the 4. So based on the situation, we note that x must be greater and equals to 4. That is the basically domain without referring to the function or the questions. So next, what we have to do is to sketch the graph. So if let's say we have the starting point, x is equals to 4. If we substitute, automatically we will have y, which is equals to 0. So we have 4, 0. So now, number 3 refers to the coefficient of x, where we have the positive. So means that the direction of the graph will be something like this. So kindly focus on the graph. So now based on the situation, we have here 1, 2, 3, and 4, and then 5. So if based on the situation, we have 4, 0. So here will be our starting 4. And then we have the graph something like this. So that is the graph for fx. So here we have 4, 0. Then kindly refers to the situation in here. Notice that x must be greater than 5. So means that we have to erase this part. So if we erase this part, meaning that the graph must be starting from 5. So the point will be 5 and then 1 over 2. If we substitute 5, then we will have 1 over 2 based on the situation given. Next, focus on A. We are going to find the range. So refers to the graph, the minimum value will be 1 over 2. So the range will be 1 over 2 until infinity. Continue. We need to find the inverse. So y is equals to fx. F inverse of y, where we have x. So let's begin. Y equals to 1 over 2 square root x minus the 4. So we have 2y and then bracket square, then we have x minus the 4. Then x is equals to, we have the 4y squared plus with the 4. So that will be the inverse. So rewrite the situation f inverse of x where we have 4 bracket x squared plus with the 1. So the domain for the f inverse, actually is the range for the f. So in here we have the situation 1 over 2 until infinity. Whereas for the range for the f inverse actually is equals to the domain for the f where we have 5 until infinity. So that is the answer for part B. Next is to sketch the graph. So what we have to do is to flip the situation. Based on the situation here where we have y is equals to x is the reflection axis. So here we have 5, 1 over 2. So if you flip, it become 1 over 2 and then 5. So 1 over 2, let's say over here, and then 1, 2, 3, 4, 5. So here will be the situation 1 over 2 and then 5. So that is the f inverse of x. Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kali refers to A. We have limit when x approaching infinity for the function given. So in here, my suggestion is to factorize the x squared. So limit when x approaching infinity. So focus on the inner function, factor out the x squared. So here we have 3 plus with the 7 over x minus 1 over x squared. Over, we have x squared bracket 1 plus with the 5 over x squared. Bracket, we have 1 over 2. Can we simplify the inner function? So limit when x approaching infinity. So we will have 3 plus with the 7 over x minus 1 over x squared over 1 plus with the 5 over x squared. We have power 1 over 2. If we substitute the infinity, we will have 0, 0 and 0 this part. So as a conclusion, the value of y will be approaching square root of 3. Or we may write it in more detail. The horizontal asymptote y is equals to square root of 3. Next, Kali refers to B. The function f is defined by the function given where we have the piecewise function. So my suggestion would be illustrate in a real number line where we have the 0. So we have the SET2. So on the left, we have 4 over square root of 4 minus the x. On the right, we will have x over, we have the square root 1 plus the x minus the 1. So next, focus on the questions. Shows that limit when x approaching 0 from the left, then we have limit when x approaching 0 from the right. So kindly focus on the left hand side. So we have 4 over the square root of 4 minus the x. So if we substitute 0, then automatically we will have 4 over the square root of 4 where we will have 2. So limit when x approaching 0 from the left for the function fx, and we will have the value of y approaching 2. Next, focus on the right hand side. We have x over the square root of 1 plus the x minus the 1. If we substitute, then we will have 0 over 0 where we have the indeterminate form. So in here, my suggestion will be multiplied by the conjugate. So limit when x approaching 0 from the right. So we have x over square root of 1 plus the x minus 1 multiply with square root of 1 plus the x plus the 1 over the square root of 1 plus the x plus the 1. So kindly expand only the denominator part. So limit when x approaching 0 from the right. So here we will have x bracket square root of 1 plus the x plus the 1 over, we have the 1 plus the x and then minus with the 1. So from here, we notice that we can eliminate this part as a 0. Then x over the x, then we will have 1. So limit when x approaching 0 from the right, we will have square root of 1 plus the x plus the 1. So limit when x approaching 0 from the right for the function fx, the value of y will be approaching 2. So from here, limit when x approaching 0 from the right, fx, is the same for the limit when x approaching 0 from the right. So limit when x approaching 0 for the function fx, we will have the value of y approaching 2, and we can consider the limit exists. So kindly refers to the number 2. Determine whether the f is continuous or not at x equals to 0. So step number 1, we must have f0. If it refers to the real number line, we have square root of 2. Second step, limit exists or not. So in here, the limit exists, where we have the value of y2 and the limit exists. Step number 3, f0, is it equals to limit when x approaching 0 for the function fx? So the answer is no. So if like that, number 4, fx is discontinuous at x is equals to 0. Hello everyone, in this video I'm going to discuss the example for differentiation. Given the equation of the curve is where we have exponent y equals to x squared plus theta 3 over x minus the 1, where the x must be greater than 1. Next, the question asks us to show the first derivative where we have given in the questions. So my suggestion for this case would be ln both sides. So if I ln both sides, so we will have ln bracket x squared plus theta 3 over x minus the 1. So we will have y which is equals to ln bracket x squared plus theta 3 minus ln bracket x minus the 1. So differentiate the situation. Then we will have 1 over x squared plus theta 3 bracket 2x minus 1 over x minus the 1. Next is to equate the denominator. So in here we have 2x multiplied with the x minus the 1 minus bracket we have the x squared plus theta 3 over we have the x squared plus theta 3 multiplied with the x minus 1. So in here we have 2x squared minus with the 2x and then minus the x squared minus with the 3 over we have the x squared plus theta 3 bracket x minus the 1. So dy dx, where we have x squared minus the 2x minus the 3 over we have the x squared plus theta 3 multiplied with the x minus 1. If we factorize the situation, and we will have x minus the 3, x plus theta 1 over we have the x squared plus theta 3 and then x minus the 1. So that would be the dy dx or the first derivative. And double check, we already shown the situation given. Continue number 2. Find the coordinate when the dy dx is equals to 0. So when the dy dx is equals to 0, then we can see that 0 which is equals to x minus the 3, x plus theta 1. So x will be equals to 3, x will be equals to negative 1. Since the x must be greater than 1, so x equals to 3 will be valid. Next is to find the value y. So kindly substitute the 3 into this part. So we have e y equals to 3 squared, where we have 9 plus theta 3 over 3 minus the 1, we have the 2. So in here, 9 plus theta 3, we have the 12 over the 2, so we have the 6. So y will be equals to ln 6. So the coordinate will be 3 ln 6 when the dy dx is equals to 0. Next, kindly refers to b. So given the parametric equation where we have the x which is equals to secant theta, and then we have the y which is equals to ln bracket 1 plus theta cos 2 theta. So question asks us to show the dy dx. So first of all, we have dx d theta. Differentiate the same, then we have secant theta tangent theta. Try to simplify the situation. So here we have the cos theta, and then here we have the sine theta over the cos theta. So the dx d theta, where we have sine theta over the cos square theta. Continue. We have the dy d theta, which is equals to 1 over 1 plus theta cos 2 theta. If we differentiate the cos 2 theta, then we will have negative sine 2 theta and then 2. So dy d theta, where we have negative 2 sine 2 theta over we have 1 plus theta cos 2 theta. So next we have the dy d x, where we have negative 2 sine 2 theta over, we have 1 plus with the cos 2 theta. So do remember to flip the situation. So here we will have cos square theta plus we have the sine theta. So try to simplify the situation. Negative 2 bracket, we have 2 sine theta cos theta. Multiply with the cos square theta over 1 plus, we have 2 cos square theta minus the 1, multiply with the sine theta. So we may simplify the situation. So dy dx, which is equals to, we can simplify this part, okay, and then after that we can simplify this part. So we can simplify this part as well. Then we have negative 2 cos theta. Then we already shown the answer for the number 1. Kindly refers to the second one. Find the second derivative. So we have to differentiate the dy dx with respect to d theta. Multiply with, we have the d theta dx. So kindly differentiate this part. We have the negative 2 bracket negative sine theta multiply with the d theta dx. So here we will have cos square theta over the sine theta. So finally, for the second derivative, we have the situation 2 cos square theta. Next, substitute when the pi is equals to pi over 3. So pi over 3 means that we have the 60 degree. So if you substitute 2 cos 60 bracket square. Cos 60 when we have 1 over 2, if it's square we will have 2 multiplied with 1 over 4. So the second derivative will be equals to 1 over 2. Hello everyone, in this video I'm going to discuss the example for application of differentiation regarding the optimization problems. A closed right circular cylinder. So here let's say we have the right circular cylinder of the base R and the height we have the h. Has a volume, so we have the V which is equals to 54 pi cm cube. Shows that the S, the total surface area of the cylinder, is given by written in the questions. So the suggestion would be formula for volume pi r square h. Continue with the area. So area we will have 2 pi r squared because of the top and also the bottom, and then we plus with the body 2 pi r h. So based on the situation given, A actually is the S. So now what we have to do is to find the h. So refers to the situation, we have the 54 pi equals to pi r square h. Rearrange, h is equals to, we have the 54 over r squared. So kindly substitute. So S is equals to 2 pi r squared plus with the 2 pi r bracket, we have the h 54 over r squared. Simplify. So 2 pi r squared plus we have the 108 pi over the r. So kindly rearrange the situation. So S will be equals to 108 pi over the r plus with the 2 pi r squared. So we already shown the situation given for the A. Kindly refers to B. The question asks us to find the value R which makes the surface area minimum. So step number 1, we must have the situation S is equals to 108 pi over R plus with the 2 pi r squared. S in terms of R. Second step, find the first derivative ds dr, where we will have the situation negative 108 pi over r squared plus with the 4 pi r. So that is the first derivative. For the second derivative, we will have the situation 216 pi over the r cubed plus we have the 4 pi. Third step, find the s prime equals to 0. So in here we have 108 pi over r squared equals to 4 pi r. So r cubed equals to 108 pi over the 4 pi. So r cubed will be equals to 27. So r is equals to 3. So let's test the situation. If r is equals to 3, so the s double prime will be equals to 8 pi plus with the 4 pi. So in here we have 12 pi, which is greater than 0, and we can consider minimum value when the r is equals to 3. So find the value of r which make the surface area minimum. So r would be 3 cm.
Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.